My name is Dave Whaley. I work for ARM, and today I want to talk a little bit about moving the Android ecosystem to 64-bit. A little bit about me. I've been at ARM for just under 2 years. Prior to that, I worked at Intel for a while, but also worked at Motorola Mobility. Been around the Android ecosystem for a long time, and it's sort of near and dear to my heart, so it's sort of a fun topic for me to talk about. So with that, I'm going to talk a little bit about these topics today. I'm not going to go through the agenda, but this is sort of the stuff that we're going to be touching on. And I think probably, I'm not sure how much you guys know about ARM, but ARM has been around for about 26 years. We've shipped about 125 billion chips with ARM technology in it. We account for about 95% or more of smartphones in the market today. The interesting thing is we've actually shipped 20 billion chips just in the past year alone. So the sort of the ramp up of volume that we're shipping is pretty significant. 70% of the global population is reached by ARM. So it's a technology company that's sort of behind the curtain, but we've done a lot of interesting things. We do a lot of partnerships. Android is very near and dear to our heart, so that's what we're going to talk about today. Sort of how we got here. ARM introduced the 64-bit instruction set architecture back in 2011 with ARM 8. It added some advanced SIMD support and scalar floating point, and that's sort of the very first place where 64-bit mobile was available. Shortly afterwards, in 2014, Google released Lollipop. That is the very first version of Android that was 64-bit compliant. They also replaced Dalvik with the Android runtime. We've been working very closely with the ART team ever since, optimizing the runtime for ARM, and we've sort of had a lot of time to make some very good and very performant changes to our code. So it's been a good thing. And then Android Pie, which was just released back in August. This is really the very first, and this still supports both 32 and 64-bit, but there was a change to Android Pie to the compatibility definition document that for the first time allows a 64-bit only version of a device that's Android. So that's fairly significant because there was an announcement that Google made back in December of last year that starting in August of 2019, Google Play will be requiring that applications that are new or updated coming into the Play Store, to the Play console, be 64-bit capable. 32-bit's not going away, but 64-bit is going to be required. If you read the Google blog post that announces this, it's from I think it's mid-December of last year. They talk about a 64-bit only future for Android, and that's something that ARM is very supportive of. We think it's a good thing for the Android ecosystem, and I'll tell you why here in a little bit. So, as I mentioned earlier, we moved from a 32-bit architecture, which is ARM 7, and I apologize if I'm sort of geeking out a little bit on hardware here, but basically we moved to ARM V8 in 2011, where we started adding a 64-bit side to the architecture. In 2018, we added even more. Some of the things that we're most concerned about, besides performance, and performance to us means not just speed, but also battery life. We're also very concerned about app security. So we're adding some instructions around memory tagging, pointer authentication, branch target identifier. These are all things that sort of keep applications in their own lane and do the right thing. If you notice, a lot of these, or all of these, this functionality is 64-bit and not available in 32-bit. The reality is that we're actually running out of instruction space in the 32-bit architecture. So going forward, we need to start doing more and more on 64-bit and doing more optimizations there. So that's what sort of our current trajectory right now. So as a Android developer, why should you care? I think that in general, 64-bit apps will tend to load faster, fetch larger chunks of data, power down faster. They're actually more performance, potentially more battery life as well. App security I mentioned, compute-intensive workloads, things that are coming like machine learning, artificial intelligence, those sorts of things. Even some of the immersive games where we're looking at as many frames per second as we can possibly generate. Those are things that 64-bit more easily supports than 32-bit. For Java apps, I mentioned earlier that we've been continuing to work with the Android runtime. If you have a Java app that has no 32-bit libraries in it, like potentially you might have maybe an analytics library or something that's included. If it's 32-bit, the app will run, or Art will run it as a 32-bit app. So you want to make sure if you have Java apps with embedded libraries, make sure that they're also 64-bit, and then you get full performance out of your application. We really think that this does sort of future-proof your app because Google is going to be requiring 64-bit support. This is a sort of do it now. You're going to be well set up for in the future. You're not going to be able to, or not going to need to recompile it in the future. It's very likely that you'll see more and more 64-bit only instructions coming from ARM, and it's just sort of what's going to be happening most likely. So I think it's a good thing. This is maybe my own personal opinion, but 64-bit Android is a little bit cleaner, and this really relates mostly to having a single ABI that you're supporting, where you're not duplicating ABIs and the resources that are required to support those those binary interfaces. So those are all sort of benefits for why you should be interested in moving to 64-bit. So this past spring at Google I/O, Google touched on a couple of, three sort of pillars that they're most interested in: security, performance, and good interactions with apps. Security and performance are two things that ARM is also latched onto as very important moving forward with Android. This is just an illustration of sort of how creative some of our developer friends can be. This is an illustration of sort of what's happening in the game industry with piracy, where they're taking an app, adding their own ad server, and then redistributing the app on a separate marketplace, and basically really stealing ad revenue from you. So my point here really is that the hardware features that ARM is including in its current architectures really support stopping these sort of side attacks and preventing these sorts of things. So things like memory tagging and pointer authentication, basically those things detect whether a pointer is pointing where we expect it to point. And memory tagging really creates a union between the call and the referenced memory, so that there can't be sort of a side attack. And those are all sort of come as part of the V8 architecture, which is again 64-bit. So hopefully those are are things that you care about as well. I think that's a pretty common theme these days. So in terms of performance, what we've been seeing sort of through the years here is performance is just increasing all the time. We see about a 2.5 times increase since 2016 to 2020. That's what we're forecasting. So we really think that year over year this is a very good trend, and this is really performance that's not. This is actually also relating to battery performance. I mean, this is not. We're not hurting battery performance by getting this sort of CPU performance as well. So these are things that again that are very near and dear to our heart. So really the mobile world is changing. Again, this is what sort of what I believe is really what needs to happen. But you get additional performance gains through using the 64-bit architecture. Power efficiency gains. You don't want your app to be the one that drains the battery. So those are things that we're very conscious of. And then really in the next 4 years, we believe that we're going to see greater than 3 times and greater than 4 times performance for integer and floating point math. Machine learning workloads that we're currently forecasting, we're forecasting about a 20% or 20 times increase in the performance that we're currently seeing. So security, again, these are things that we're focusing on. The microarchitecture and architectural features. We're trying to keep side attacks at an absolute minimum. Again, these are things that I've mentioned, but the pointer authentication sort of thwarts a lot of the return-oriented programming attacks, where the branch target identifier supports the jump-oriented programming attacks or thwarts those as well. What we really say is if there's hardware defense, then the apps are definitely much more secure. Sort of moving on here and talking a little bit more about some of the use cases that we're seeing around mobile, and we really believe require 64-bit support. Immersive gaming, a lot of the machine learning. I think there's still debate on how much of that happens on the client device and how much happens sort of at the edge or on the cloud. But there's still going to be a lot of compute required for machine learning applications. We're getting requests for 60 frames per second and beyond for gaming and video, and that's just basically requires raw CPU. Again, 64-bit is where that capability is going to be available. So I'm going to talk a little bit more about sort of how many devices are out there today that support this. So about 80% of the devices that ship today support both 32 and 64-bit. Lollipop, which is required to run 64-bit apps, about 88% of devices that ship today have Lollipop or greater or later. So there's about 12%, and it's decreasing all the time, that currently couldn't run a 64-bit application. And then lastly, this is a little bit of a misnomer, but premium devices. And premium devices are devices that ARM, we define premium as anything that's selling price of, say, I think about $400 to $500 and above. All of those are capable of running 64-bit apps today. One of the things that you need is memory. So based on requiring probably you pretty much need a 2 gigabyte part, DRAM part, in order to run 64-bit Android. and that's probably the minimum. But one of the things that we're trying to ascertain is, how fast are those disappearing? In lieu of larger resource devices. Strategy Analytics helped us with this. They believe that next year, over half of the demand for DRAM for devices, and really my point is here is that I want to make sure that if you're doing a 64-bit app, you're not leaving some of your users behind because they don't have the resources to actually run that app. But by 2023, 95% of the smartphones that are out there will have 4 gigabytes or more. So my point here is really that you're really probably not losing many. You're not leaving many users behind if you start supporting 64-bit. So that's what I'm talking about there. So Android, sort of the migration timeline. There's been quite a bit of stuff happening around 64-bit. I mentioned here that Google announced the 64-bit play requirement back in Q4 of last year. Both Unity and Unreal have done 64-bit engines for their Oculus portions of their engine. That was announced at GDC earlier this year. Also, if you follow the Google or Android developer blog, you'll see that they're actually deploying 64-bit apps a little easier and a little bit more streamlined. I'll show you some things later about what Google's been doing to support what could be larger applications, because 64-bit pointers are a little bit larger and your apps could potentially grow a bit. So Google's been doing some things sort of behind the scenes that I'll share with you. But earlier, just a month or so ago, Unity announced that they're supporting 64-bit for their 2018.3 engine. Android Pie, which I mentioned earlier, now supports 64-bit only devices. And then by Q3 of next year is when the mandate kicks in for having a 64-bit capability in your app. So sort of in the future, we believe that we'll start to see 64-bit only devices. And I have a bunch of links at the end. The very first Google announcement actually mentioned that Google's actually very supportive of 64-bit only, but there are some ecosystem hurdles that we have to get over. Things like some of the markets where Google may not have as much influence, Asia, those sorts of places. We want to make sure that we're not sort of stunting the growth of some of the emerging markets where there aren't a lot of system resources on the devices. So I think it's going to be a while out before there's 64-bit only. But even for the emerging markets, when we see the cost of DRAM come down to the point where a 2 or 4 gigabyte part is cheaper than a 1 gigabyte part, you're going to start seeing that capability that available to all users. So taking advantage of 64-bit today, I mentioned performance a lot. Here's some actual benchmarking data that we've done. So you see this one is actually for Android runtime for art. So we're seeing overall about the very end column on the right shows about a 20% performance uplift right off the bat with moving from 32 to 64-bit. You'll see there's certain things that it does much better, but overall about a 20%. You get a 20% increase by recompiling or making sure that your Java app doesn't contain any 32-bit libraries. Very good numbers. For native apps, we did a Geekbench comparison. Anywhere from about 7.5% to 15%. depending on sort of which Cortex processor you're using. But in general, again, this is sort of just recompiling for 64-bit, and you basically get that right off the bat. So pretty good numbers. One of the things that's also happening is Enyo and Demos are internal names, but Enyo is actually the Cortex A76, which has been launched. Demos has been announced, so this is a legal slide from my standpoint. But what we're seeing is we're actually seeing an increase in the amount of uplift that we're getting over time. So as we're moving to newer chips down the road, we're seeing more. So Enyo, which is the first chip, got about 2 to 3% right off the bat, moving to 64-bit. Demos, we're seeing about 8%, and there's some unannounced chips that we're seeing more. So it's starting to sort of move up into the right pretty quickly. So we think that AR64. I'm sorry, I use AR64. There's a bunch of names for it, but the instruction set architecture, 64-bit, is really it allows us to. We find larger optimizations with less effort in 64-bit than we do in 32-bit. I mean, 32-bit has been around for a while. We've sort of wrung out a lot of the performance that we've been able to find, and we're finding more performance in the 64-bit architecture faster as time moves on. So that's a great thing for the whole Android ecosystem. So the next thing I'm going to show you. Stop. Is I'm going to show you a little demo. So some of our guys took the Unity engine, well, you saw this little sneaky game there, but we wrote a little demo using some physics engine, audio, using sort of capsule collider, bunch of animation, using AI for collision avoidance, and compiled it for 32-bit and for 64-bit. And these are ARM developers that may not be super gaming developers, and basically they got about a 12% frame rate increase right off the bat. So we think there's probably even more available. But without further ado, here's the demo. So basically what you're seeing is up to about 200 of these little soldiers. If I had audio on, you would see when they got killed, there'd be screaming in 3D audio and all that sort of stuff. But it's using and I don't know all the terminology here, but it's basically using, I think, nav mesh for obstacle avoidance, and it's really only doing some of the hard things when there's explosions and there's people flying about, and so it's actually a pretty interesting. I think the physics engine is only used when there's explosions and the guys are flying about, so you see them jump out there. So anyway, that's the demo. Sorry. One other consideration for developers is my app's too big. And I mentioned this earlier that with 64-bit, the pointers are larger and your APK could be a little bit bigger. So I'm not saying that Google's been doing this in support of 64-bit necessarily, but because they've noticed that APK sizes have been growing dramatically, and that quote is from their developers blog, 5 times the size since 2012. They've been starting to do some interesting things. With App Studio 3.2, they added app bundles. This basically allows for distribution of smaller app sizes. They quoted between 11 and 64% app size savings. Sort of in league with this is Google Play's dynamic delivery, which basically looks at the manifest of the device that it's downloading the app to, and downloads only what is needed. Again, this saves a lot of space. And then just about 2 weeks ago, at the, I guess it was the Android Developer Conference at the Computer Museum, they announced the 3.3 beta of Android Studio, and there's what they're calling the R8 app shrinker, which is more, I think it's more compression than anything. I haven't really dug into it a whole lot yet, but they've basically recognized that that apps have been growing. Moving to 64-bit isn't going to help that at all, but these things should help mitigate any increase that you see because of moving to 64-bit. So that's good. I mean, it's a good thing that's happened. So with that, I have a summary here. So really the advantages are around security, performance, future compatibility of your apps. We think it's a great thing. Sort of everybody benefits if you move to 64-bit. The majority of devices, hope I convinced you that they support 64-bit today. And it's just going to be growing. That majority will be growing as time moves on. The current mainstream markets, if those are the ones that you're after, are pretty much all 64-bit today. So sort of have at it. And then we see that there's more and more 64-bit or AR64 only architectural features coming. We will probably be placing less emphasis on new things for 32-bit and really just fixing bugs and making sure that it continues to perform into the future. But the new instructions are most likely going to be just 64-bit. So with that, what we're really asking you to do is start building your apps now. I mean, if you weren't aware of Google's mandate for the Play Store, I have some links for you to follow up and read. But we urge you to move to 64-bit as soon as you can. One of the things that we've been doing is we've actually been tracking some of the more popular apps globally, and I personally have reached out to some of those companies and asked them, if they were aware of the mandate, what they were doing, what sort of what they thought about it, and some said, yeah, we know about it. We're actively moving our app. Some believe that it's just simply a recompile. In all likelihood, if you're currently updating or supporting, I should say, both iOS and Android, you probably have a 64-bit version pretty close already. iOS has been 64-bit only for about 2.5 years, so you most likely are pretty close, and it might be, if you've written your code well, it might be simply a recompile to get to a 64-bit version. Really, I think it's important for you to start shifting to 64-bit. Actually, App Studio defaulted to 32-bit compiles up until about less than a year ago. Now it's defaulted to 64-bit, but basically start using testing, optimizations, all should be sort of 64-bit focused at this point. Really look closely at your native and Java apps. Upgrade any 32-bit libraries or engines that you're currently using. Things like analytics that you might have licensed and used in your app might be 32-bit. You might want to take a look at that because those would be something that would potentially slow you down. If you use Neon, which are sort of, if you use the Neon assembler stuff, you'll probably want to change to the Neon intrinsics and do that a work. I mean, if you don't use Neon, that's fine. But Neon basically is some hand-coded speedups that you might look at. I have a whole bunch of again, links to the ARM content that explains all of this. And then check out our white paper, which was actually published today in support of droidCon, and it should be there. So so that is summarization. Here are some things that these are a lot of sites that I look at almost daily, and really it's more. Developer.android.com is a great resource. This link here actually talks about sort of what considerations Google sort of wants developers to know when they're doing 64-bit builds. Let's see what else. This is the developer blog. The developer blog has a lot of great information. There's probably a post there about every other day, anything ranging from sort of what's happening with Google Play to beta releases of Android Studio. So I think these are all places. On this side, there's a bunch of information around some of the architectures. Sorry, not turning the mic. But there's a lot of information here on the ARM v8 architecture, the instructions that are available to you, and yeah, I mean, there's a ton of information out there. So I'd recommend that you look at these weekly, at least. So with that, that's pretty much what I had to share with you today. If there's any questions, be glad to answer. Otherwise, you can start thinking about it. It's getting dark out. So thank you.